Today I am here to prepare a short video regarding 1-bit memory. Okay, how to perform this experiment in our physics practical lab. So without any delay, I would like to move towards my practical. Okay, before starting our practical, we need to have a little bit knowledge about 1-bit memory. What type of memory is called 1-bit memory? Okay, but before that, we will learn about the NAND gate. What type of gate is known as a NAND gate? Okay, um, what type of gate is called a NAND gate? We'll not learn about that. Right, to pick this color. Okay. At first, we have here A and B connection and Y is the output. This is called a NAND gate. Okay. And if we see the truth table of this NAND gate, we can see over here that if both A and B is 0, if both A and B, if here is also 0 and here is also 0, then output will be 0. Okay. If both 0 and 1, A and B is 0 and 1, then output will be 0. If 1 and 0, output will be 0. If 1 and 1, output will be 1. So let us remember what type of output we get from this AND gate. Okay, sorry, this is AND gate. This is NAND gate. Okay, I forgot to write here AND gate. I'll mention it over here, AND gate. This is AND gate. If there is a little small bubble here in AND gate, we call it as an AND gate, but we are here in AND gate. Okay, how to remember this output in AND gate? If both input is 1, then only output will be 1, otherwise the output will be 0. Or we can simply remember by multiplying these two. If 0 0 0 multiply 0 0, 0 1 0 multiply 1 0. Okay, 1 0 0 1 1 1. Okay, we can remember this thing, but the simple logic is if both input is high, then only we have a high output, otherwise the output will be low. Okay, this much. And if we simply place here a bubble, then it means a NOT gate. This AND gate is passing through a NOT gate and it is simply being a NAND gate. Okay. What is the meaning of this bubble is whatever the output which is given by this AND gate is passed through simply another gate. We call it as a NOT gate. Okay. And the output will be changed. Okay. And the output will be changed. So this type of gate is called NAND gate. Okay. Suppose if both 0 here, then we'll have 0, but here we'll have 1 because this 0 is changed to 1 with the help of this bubble. So here we can remember that if both 1, then only the value will be 0. Otherwise, the value will be 1. Okay. And here what do we know is this NAND gate is 0 sensitive gate. Okay. This NAND gate is 0 sensitive gate, and if any one of the input is 0, then output will be high. Okay, if any one of the input is 0, then output will be high. Otherwise, the output will be low. Okay, let us remember like this. If A or B, if both A and B, or if any A or if any B is 0, then definitely our output will be 1. Okay, suppose let us think here. If A is 0 and we have not given anything to B, then what will be the output? We can predict the output. It is simply 1 because whatever be the value of B, the value will be 1. So we can take this NAND gate as a 0 sensitive gate. Okay, 0 sensitive. Whatever the value will be given on other side, if any one term is 0, then the output will be 1. But same thing cannot be predicted by this thing. Suppose I want to erase this. Okay, if here is 1, okay, then we cannot say the output will be 0 because this will be the decisive term. Because if here is 1, definitely output will be 0. But if here is small 1, 0, but then the output will be high. Okay, so let us remember this thing. Let's be sure if any one of the input is 0, output will be high. Okay, in NAND gate. And now we'll talk about the NOT gate. What type of gate is called NOT gate? We'll take a transistor. Okay, it is a emitter, it is a base, and it is a collector. Sorry, this is base, this is a collector. Upper one is collector, this arm is collector. So we'll place the certain value of resistor, okay, emitter will be ground, base will connect to 10 kilo ohm resistor, which color code is brown, black, orange. Okay, here is also brown, black, red. Okay, here will be the input, and from here we'll take the output. And this collector will be given to 1 kilo ohm resistance, and 5 volt plus 5 volt will supply over here, and we'll get the output. Now, what is the meaning of NOT gate? NOT gate is simply this bubble. Okay, we can use this type of gate also, or we can make a separate NOT gate, and we can attach this NAND gate to this NOT gate to make AND gate, NAND gate, sorry, AND gate to NOT gate to make NAND gate. Okay, otherwise we can have a simply this type of NAND gate in our physics lab in certain IC. I'll talk it about later. Okay, this is a NOT gate. Okay, I want to zoom it a little bit. It is a NOT gate. So here is the input. Whatever the input we give, the output will be inverse, or we can tell it as a complement. Okay, output will be complement. Suppose if input is 1, then output will be 0. If input is 0, output will be 1. Okay, we can talk about this, how it is possible. It is a basic term. Okay, I don't want to go there, but simply let us understand this thing. The symbol of NOT gate is this thing. Okay, and we can use a NAND gate to make a NOT gate. Suppose from here, if we combine the 3-input NAND gate into this 3-input, 3 arm will become combined to get a one terminal, and the output will be other. Suppose whatever we place here, if we place here 1, then all the input will be 1. Then what will be the output? 1, 1, 1, 1, 1, 1, 1 multiply 1 multiply 1. The working of AND gate is 1, output is 1, but there is a NAND gate. Then AND gate will pass through NOT gate. That means 1, if it is passed through NOT gate, we'll get the 0. Okay. And simply if there is 0, we'll get 1. Okay. Okay. Now we need to, before going to 1-bit memory, we need to know about these two IC 7400, 7410. Okay. In this 7400 IC, we can see a little bit this type of mark in IC. We'll keep it towards the left side, and after that, after that we can connect this IC. Okay, let us see how this IC is composed of. Okay, this IC is composed of several 2-input NAND gate. We can see here 1, 2, 3, and 4 NAND gate are there, which have a 2-input. If we talk about 7400 IC, we need to remember there is a 2-input NAND gate. So here, whatever before joining this IC in our breadboard, okay, before joining this IC in our breadboard, we need to fix 14 as a plus VCC. We need to give at first 14 plus VCC, and we need to give 7 ground at first. Otherwise, the IC will not operate. Okay, this is the basic requirement for the operation of IC, and we know in breadboard, okay, in breadboard, IC cannot be kept wherever we like. Okay, there is a 2 partition in breadboard, and up there is a partition for supplying a VCC, and down there is a partition for supplying of ground. Okay, neutral, we can call this neutral. Whatever we can take, down we can take VCC, upper one we can take neutral, and we need to place the IC here. Okay, so that its upper leg touches the upper one, and the lower leg touches the lower one of this second and third terminal. Okay, don't be sure, don't place a IC over here, it is totally wrong. Okay, it is totally wrong. We need to place this IC over here, and we need to know where is the terminal. Suppose 1, 2 is input, 3 is output. We can give this 2 input, and we can take from here output. We can give 2 input from here, we can take output from here. This is already ground. We can give 2 input over here, 10 and 9, we can get output from 8. We can give 2 input from 12 and 13, we can get output from 11. Okay, same thing is here in the IC 7410. What is the difference? Difference is that the same NAND gate is here 3 input 1. Okay, suppose the input will be given here 1, 2, and 13, and output will be taken from 12. Okay, this is one compartment, and this is another compartment, and this is another compartment. So we are clear from here that 7410 IC have 3 input NAND gate, and which is composed of 3 part inside that IC. And here there is a 2 input NAND gate, and there is only 4 IC, or not only, more than the 7410. There are four NAND gate in that 7400 IC. Okay, I hope I made you clear till here. Okay, I want to erase all my drawing. Where can I erase? Okay, let it be. Now we'll move towards the other terminal. Little bit down. Okay, now we are here in the circuit diagram of a 1-bit memory. Okay, now we have this type of compartment. As I already told you, here is a little bit mistake. Okay, this 2 point is not joined. Okay, I want to remind, this 2 part is not joined. What is here is, this is separately connected with this, and this is separately connected with this one. Okay, as I already told you, this NOT gate, you can use NAND gate as a NOT gate, but combine, don't forget to combine this. Okay, we can use this as a NAND gate. Okay, NOT gate, sorry. These two NOT gate are there. Here are three compartment. Okay, one here is address, read, write, and here is data. Okay. And we'll connect this. Okay, we know that this is from the IC 7400 because there is two input. Here is two input, 7400, 7400. We know that in 7400 there are four compartment for NAND gate. We'll use only three compartment. We'll leave the other. And here three input NAND gate, three input NAND gate. Okay, then in NAND gate we have three compartments, so we'll leave one, we'll take only two. Okay, let's give numbering from your own side, because you need to know how to give numbering, how to place this. Let's work hard little bit. Okay, you can know it later. And I will talk about this. What do you mean by 1-bit memory? 1-bit means, we know that 1-bit means either 0 or 1. Okay, this is bit. Okay, it can store, memory means it can store either 0 or 1, and here we can get the stored data in next follow up. Okay, in next our next follow up, we can get those data which we store in our previous what do we call, previous work. Okay, in our previous work, we'll store data, and later on we'll recall that data whether it is stored correctly or not. Okay, this is the simply thing. Memory means to store and to take out. Okay, suppose in our examination we'll store in memory, and in exam paper we'll take out whatever it is stored. Okay, it's simply this thing. We'll connect this and we'll see how it works. Okay, at first, we'll give this address. Address is X, read, write, and data. X will give, I want to draw here one line. What to draw here? Okay. If we give the address 0, if address is 0, then this NAND gate, if any one input is 0, output will be high. Then we don't care about this all. Okay. Although Q is the last state, we don't care this all. Y will be 1. But the result is false because we didn't give anything to store before. Okay, it is simply showing 1. How it can show? Okay, so it is a false result. Okay, whatever we can give here, all the result will be Y. As I told you before, in NAND gate, if any one input is 0, all the output will be high. Okay, we don't care about this all. And next thing is that we'll give 1 1 0. That means address will be 1, read write will be 1, data will be 0. That means if the read write term is 1, then we are writing a data in a memory. Okay, what type of data we are writing? We are writing this data 0. D means 0. No, at this case, if read write is 1, that means we are writing the data. Which data? This data, that is 0. Okay, we are writing 0 in a memory. So I want to drop this because it may make a little bit confusion. Okay, now at this case, if here 1, and here 0, then what happens? Then it happens that 1 means this terminal will be 1, this terminal will be 1, and here, from here it will be 0. If it is 0, then output will be 1 directly. See here, output is 1. But this is correct output? No, because we haven't stored any data. Before we get output, we need to store data, and then only we can see the output, whether the data is correct or not. That means we are writing 0. Where we are writing 0? In a memory. Later on, I say at this step, how we are writing 0 in a memory, and the output is obviously false because we haven't written any data. It is showing the result 1. So we'll write here, we'll take here 1, we'll take here 1, we'll take a 0. So this compartment is fulfilled, we'll get output, we'll get the output 1, okay? Oh, sorry, I have made a little bit mistake over here. Here will be one little bit terminal connected, okay? Here will be one terminal connected over here, okay? There will be one terminal connected. So no matter, okay, no use, because before at this case we have x0. If this is 0, we don't care about this all, we'll write directly output 1. And in this case also data is 0, and this read write is 1, read write 1, then from here read write 1, it coming here, and from here it will be automatically 0, and the output will be 1. We don't care about this. Whenever there is a use, then only I remind this thing, okay? Now at this case, what happens actually, we'll get the output false, but what about the other terminal? See here, okay? We have already finished this. Now we are over here. From this terminal, we are getting 1. So there is no any judgment of output. From here, we are getting 1. And from here, we are getting 0. That means this 0 will be 1. Then all the terminal is 1. Then the output will be 0. Okay. If output is 0, we don't care about this thing. Then Q will be automatically 1. Here is Q is automatically 1. Okay. Because we don't care about this. And this, let us talk about this thing. Okay. Q is automatically 1. And here what happened? 1, 1, 0. There is no any NOT gate. So we can say that from here 0 is coming. So the output will be 1. So we cannot predict this. This is the required thing. So from here 1 is coming back. That means if 1 here, then 1 here, then this Q will be 0. Then Q 0, then obviously Q is 1. So this is fulfilled. Now, what is the use of doing this? The use of doing this is storing 0 in the memory. Okay, you can see this type of compartment over here. Okay, I hope you can see this compartment. This compartment is a memory. Okay, this compartment is a memory. There is a little bit flip-flop going on. Okay, this is a memory. So from here, this thing is going on. So I want to drop this. Now, we are storing 0 in a memory. Now we want to see that 0 in our next step. So before that, I would like to drop this. 0 is stored in a memory. Now in next step, how can we get those data? Okay, let us see. This I want to drop it. We have stored 0. There may be question why we are storing 0 here, why we are not reading, because the read write term is 1. That means we are writing, we are storing, okay, the data, that is 0. Now in our next step, now we are in third step, okay. Here in our next step, what we will do is we'll give X address as 1, read write 0. What do you mean by read write 0? Read write 1 means writing, then read write 0 means reading the data. Okay, over here I have given one term. Okay, I've given one term. Before the term Q was 1. Okay, before the Q was 1. So we take only Q here. We don't take Q bar. Okay. So let us see 10x. Suppose from here address is 1, 1 going here, no prediction of output. Okay. From here we are getting 0. Oh, see here, from 0 will be converted to 1. So there is no prediction of output. So output is always determined by this red line, okay, from the terminal Q. Okay, from the terminal Q. So that means whatever be the data, our output will be, from here we know that the previous state Q was 1. So 1, when it comes here, then the output will be 0. See, before we have stored 0, now we have got our result as a 0. So we don't care about the other all. Okay, so this will be the term. If we care about the other all, then what happens? Whatever be the data, you can give your data 1 or 0 or anything. Okay, if read write term is, let us talk about this, okay, in detail. Okay, from here one, this compartment we have fulfilled. What about this two compartment? This one can be changed or not? we will see about that. Okay. Okay. Now, 10 data, whatever with the data. Okay. From here, 1 is going because address is 1 for this IC. Okay. For this NAND gate, 1 from here also 0. 1 0 means obviously the output will be 1. From here also 1 0, output will be 1. So there is no prediction. This will decide 1 1 gives the output 0, and from here again 0 because this is 1. Okay, this is already 1 before. So 1 1 gives the output 0, and this 0 will give the output 1. So same thing happens, and we'll get the output 0. Now in our next step, what we'll do, we'll again write the data, because without writing, how we can read? Okay, we'll again write the data and we can read. Same thing will be followed by the data 1 now. Before we have written data 0, now we'll write data 1. So I want to go a little bit faster. If you have any trouble in this video, so you can pause and you can see it later. Drop this. I'll draw here one line. Okay, here was one line. I forgot to draw in my copy. Okay. Now in this step, read write term is 1, and we are writing the data. Which data? 1. We are writing data. So all the terminal is 1. Here is 1. Okay, and here is 1. The gives the from here it will be 0, and output will be 1. That means the output is false here. See, before the output was true. Here output is false. We know that this is 1. We cannot predict what is Q now, because Q is the previous state, not only previous state. Now this time the Q is going to change. Okay, Q is going to change. Now we'll see how this Q is 0. 1 1 1. Suppose in this IC, okay, 1 1, and here is 1. So this will be make it 0. 1 1 0 means if any 0, output is 1. Then this do not have any prediction. Now this will, Q bar will decide for this NAND gate what will get the value of Q. Okay. Here 1 1 1 1 1 1 means all the terminal is 1, and we'll get here value 0, and we'll get here value 1. So if this both is 1, then Q will be 0. Obviously, see, Q is 0. Now we are writing, okay, in this process we have stored Q as 0. We have changed the value of Q, but we are writing 1 in the memory. Okay, see, this is the fact. Okay, we are writing 1 in memory because we are writing this data. So later on process, we'll change the read write variable to 0, and we'll read same data as 1. So same thing happens, 1 0. Whatever be the data, see here 1 is going from why I'm checking this part, because this IC gives a output. So in this case, while getting the output, okay, while getting the value of output, we'll check only this thing. Here is 0. We have stored in the value of Q. Okay, memory is stored as 0, but we need to read 1 because we have given the data here. This data is shown in this step. Okay, I want to give you one arrow. This data is shown in the next step, and this data is shown in next step. See, it need to tally each other. So 1 0 means here is 1, here is 0. It makes 1 1 1. No prediction. So this will predict. This is 0. Output will be 1. That means we have stored 1 before. We are getting 1 now. So this is the completion of 1-bit memory. Okay, we can use here 1 and 0 in place of 1 and 0, 5 volt and 0 volt. Okay, you can use ground, or you can use that 5 volt. Okay, this is the thing. Hope you are clear on this. Okay, thank you very much. I would like to stop my video over here. Thank you.